Great. So we learned some rules. We learned the sum and difference rule, the multiplication, or the product and the quotient rule. We learned if it's a power function, a function raised to a power, or a radical. All we could plug in the numbers. But plugging in the numbers doesn't always work. So we need some techniques. What happens if I plug in the number and it doesn't work? So one of those techniques would be simply factoring and simplify first, and then plug in the number. Let's see what I'm talking about. Let's look at example 7 here. It says find the limit. The limit is x approaches 2 of x cubed minus 8 all over x minus 2. Well, this is a polynomial over a polynomial. It's a rational function. And we have the quotient rule says we can plug in the limit to the top, the limit to the bottom, and see what happens. Polynomials say we can just plug it in. So we're able to just plug it in this problem. But look what happens when we do. 2 cubed minus 8 is 0. 2 minus 2 is 0. We have 0 over 0, which is called indeterminate form. It's undefined. So this function is not defined at that point. Well, we need to reset ourselves a little bit. Doesn't matter what happens at the point. And the answer is no. Limits, it's not what happens at that point. It's what happens near that point. So even though it's undefined at that point, that does not mean that our limit's undefined. So what do we need to do? Well, because it's a fraction, maybe we should try factoring and simplifying. This does require, first of all, I'm just going to do some algebra. So I'm going to not write the limit. I'm going to do some side algebra over here. I'm going to look at x cubed minus 8 all over x minus 2. If you remember, and you should remember, what's the formula for factoring a difference of cubes? Because x cubed minus 8, 8 is a cubed and x is cubed. So this is a difference of cubes. Well, when I look at a difference of cubes, I always try to remember SOAP, same, opposite, always positive. That gives you your sign. So since it's a difference, it's going to be subtraction is the same. Opposite would be addition. And the last one is always positive. It's always the first, which is x, minus the second, which is 2 here. It's whatever the cube root of the number is. So the cube root of 8 is 2. Then it's the first squared. Then it's the first times the second. So that would be 2x. And then it would be the third number squared. So that would be 2 squared, which is 4. So it's the first minus the second, the first squared, the first times the second, then the second squared. Here this would be, what I'm talking about is the first, it's the first thing cubed, and then the second thing cubed. So we're talking about x and 2 here. So that's what x cubed minus 8 factors into. X minus 2 times x squared plus 2x plus 4. If you don't believe me, FOIL that out, distribute it out, verify, and double check. So that's our numerator, and our denominator was x minus 2. Well, notice what happens now. Because we're in factored form, we're able to simplify. So x cubed minus 8 all over x minus 2 is really the same thing as x squared plus 2x plus 4 all over 1, but I'm not going to put the 1 on the bottom there. So what's the idea here? When we tried doing the original limit, the x cubed minus 8 over x minus 2, we got 0 over 0. But x cubed minus 8 over x minus 2 is mathematically equivalent to this new one, x squared plus 2x plus 4. So what are we going to do? Instead of finding the limit of the nasty one, the limit is x approaches 2 of x cubed minus 8 over x minus 2. Instead, we're going to find the limit of the nicer one. So this is the exact same thing as the limit as x approaches 2 of x squared plus 2x plus 4, the factored and simplified version of it. Well, now that's a polynomial function, and we can just plug in the number 2. So that'd be 2 squared plus 2 times 2 plus 4. Put that into your calculator. I'm getting a value of 12. Notice it's not undefined anymore. So if we tried to do it the original way, we got undefined, indeterminate form, undefined. We factored and simplified and then evaluated the limit. Now we got the number 12. What's really important here, I want to make sure you do not miss writing this step down on your paper. You do need to write the limit as x approaches 2 of the simplified function and then plug in the number. We write the limit sign throughout the simplification process. We only get rid of the limit sign when we're doing our equal signs here, when we're showing our work, you only get rid of the limit sign when you're actually plugging in the number. So limit signs all throughout the beginning until you plug in the number. Okay. Let's look at the next one. It says find the limit. The limit as x approaches 3 of x squared plus x minus 12 all over x minus 3. Well, it's a quotient, so we know we can find the limit of the top over the limit of the bottom. They're both polynomials, so we know we can just plug in the number directly, so let's give it a try. If I plug it in directly into the top, it would be 3 squared plus 3 minus 12. And if I plug it directly into the bottom, it would be 3 minus 3. Well, on the top, that would be 9 plus 3 is 12 minus 12. That's a 0. And on bottom, 3 minus 3 is a 0. Again, that's indeterminate form. Indeterminate does not mean the limit doesn't exist. Indeterminate means the function doesn't exist at that point. So we need to investigate, does the limit exist at that point? We could look at the graph, we could do the table, or we could learn the sweet algebra trick of just factor and simplify first. So let's do some side math here. Let's look at x squared plus x minus 12 all over x minus 3. Is there any factoring and simplifying I can do? Well, I need two numbers that multiply to be negative 12 and add to be 1. Well, wouldn't that be x plus 4 and x minus 3? If you don't believe me, FOIL it out, double check. And on bottom, we have an x minus 3. So what happens now? Now that we're in factored form, we can simplify. Remember, you have to be in factored form before you simplify. So the x minus 3 simplify, and I end up with x plus 4. So what am I saying? I'm saying, well, when I looked at the limit as x approaches 3 of the original problem, which was x squared plus x minus 12 all over x minus 3, I couldn't do it. But what we can do is now evaluate the limit as x approaches 3 of the simplified version, which is x plus 4. And how do I find the limit of that? I simply plug in the number. So that would be 3 plus 4, which is 7. So the limit is x squared plus x minus 12 over x minus 3. Even though when I directly plugged in, the function's undefined at that point, the limit still exists, and the limit is 7. We could always check this by using the table feature on our calculator. Would help us out. Double check our math. And that's something that I really recommend doing on the test. You have that extra time, use your calculator, use that table feature on the calculator, make sure you did it right. Okay. Let's look at the next one. It says another technique that may be useful is rationalizing the numerator. Well, if you just got done doing the algebra review, then you would have seen rationalizing the numerator in the algebra review. And that's why I reviewed this, is because I wanted you to remember, what does it mean to rationalize something? So to rationalize something means to get rid of the radical. So here we're rationalizing the numerator means get rid of the radical in the numerator. And if you remember, when we have more than one thing in the numerator, and there's a radical, you want to multiply by what's called the conjugate. The conjugate being the exact same thing with the opposite sign. So here we have square root of x plus 1 minus 1. The exact same thing with the opposite sign would be the square root of x plus 1 plus 1. Okay, so let's give this a try. Let's take this one step at a time. It says find the limit as x approaches 0 of the square root of x plus 1 minus 1 all over x. So what should we try doing? Well, I do the same thing every single time. I'm always going to try just plugging in the number, because I have the quotient rule says I can do that. I can just plug in the number into the top. I can plug in the number to the bottom. But when I do that, square root of 1 minus 1 is 0, and then I have over 0, and again, that's indeterminate form. Indeterminate form here again means the function does not exist at that point, but that means nothing about the limit at that point. So at this point, I need to investigate. Look at the graph, look at a table, or let's do some nice algebra tricks. What are the algebra tricks I'm talking about? Well, let's look at the original problem, the square root of x plus 1 minus 1 all over x. Well, the idea here is I want to get rid of the radical in the numerator, and to do that, I'm going to multiply by the conjugate of the numerator. So that would be the exact same thing, the square root of x plus 1 and a 1, except you change the sign, so it's going to be positive. So the square root of x plus 1 plus 1. Let's go ahead and FOIL this out. So if I FOILed this out, the first term would be square root of x plus 1 times the square root of x plus 1, which is the square root of x plus 1 squared. The outers would be plus the square root of x plus 1. The inners would be minus the square root of x plus 1. And then the last would be negative 1 times 1, which would be minus 1. All over the bottom, which is x times, do not distribute out the bottom. Keep the bottom in factored form, only distribute out the numerator. So that would be x times the square root of x plus 1 in parentheses. So why did we multiply by the conjugate? Well, one thing you're going to notice when you multiply by the conjugate, every single time when you have two terms and you multiply by the conjugate and you FOIL, those middle two terms are going away. They're going to cancel. So we have a positive square root of x plus 1, a negative square root of x plus 1. It's gone. I also have the square root of x plus 1 squared, which would simply be x plus 1. So continuing down my path of simplification, looks like I'm on x plus 1 on top. I still have that minus 1 on top, though. On bottom, I have the x, and then in parentheses, I have the square root of x plus 1 plus 1. Well, now I notice that my 1's cancel out. I'm left with x over x times the square root of x plus 1 plus 1. And yes, I did need to do this in two separate places. A lot of you probably saw that that x was going to simplify on the previous step, but you cannot do two steps in one here. You cannot both cancel the x's or simplify the x's and cancel the 1's. You have to mathematically cancel the 1's first, and then and only then are you allowed to simplify those x's. So when I simplify the x's, I'm left with a 1 on top. Make sure you keep that on top. And a square root of x plus 1 on bottom. So let's go back. Our original problem, the original problem was the limit as x approaches 0 of the square root of x plus 1 minus 1 all over x. And we knew that was indeterminate. Well, we have now rationalized the denominator, keeping equal signs the entire time. So this has to be the same thing as the limit as x approaches 0 of the new one. When we rationalize the denominator, we got 1 over the square root of x plus 1 plus 1. Well, now let's try plugging in the 0. So I'm going to get rid of that limit sign because I'm actually evaluating the limit. This would be 1 over the square root of 0 plus 1 plus 1. Well, the square root of 0 plus 1 is the square root of 1. Square root of 1 is 1. 1 plus 1 is 2. So I'm getting, use your calculator if you're not comfortable with that, I'm getting 1/2. So even though the function's not defined at that point, we couldn't just plug in 0 at that point, we still can find the limit using algebraic techniques. In this case, the algebraic technique is multiplying by the conjugate of the numerator, rationalizing the numerator. I just wanted to give you a little bit of a hint. Hopefully you made it to the end of this long video. But I wanted to give you a little bit of a hint and let you know that one of each of these types of examples most definitely will be on the test. There will be a limit where you plug it in and you get 0 over 0 and you have to factor and simplify. Likewise, there will also be a limit where you have a radical in it. You get 0 over 0, which is undefined, and you have to multiply by the conjugate to get the answer. So one of each of these types of problems on the test, guaranteed. Also on the final exam, so just be prepared for that.